You start this one. Okay. So, hi, teacher. We are group two. So, we're going to talk about experimental determination of the spring constant using Hooke's law. So, the first one, obviously, is about the introduction. So, Hooke's law describes like how springs and elastics materials behave when the force is applied. So, it states that the force needs to be stretched and compress the spring and it's also proportional to the distance when it is stretched and compressed. But as long as the material elastic limit is not existing. And also we can see this formula is very essential for understanding the elasticity and design a system with the spring or elastic materials. Okay, the methodology. First, we attach a string to an elevated surface, and we measure the amount of displacement that the spring would have. This will be our basal measurement. Then we use known weights and measured each elongation 10 times for each weight. And we logged in this data in Excel to experimentally calculate some values, like a constant. And just to clarify, there's some source of uncertainty, which would include the Garnier, which is 0.01 millimeters, the observer's interpretation, and the parallax error. So for the data collection, here's our table from Excel. Here are the elongations for each of the weights we tested. We have a mean elongation and the standard deviation, which corresponds to our uncertainty per weight. Then on our second table, we have the conversion to mass from mass to force, so we can start calculating the spring constant. Then our second part is where we plot the force versus elongation data. So after we plotted this, we saw a linear regression was our best fit, and we verified Hooke's law by arranging all our data. Our data shown that it was arranged on a line. So our constant for the Hooke's law was the slope of this equation, which was 82.80. And all of this was further confirmed with our R-squared value, which was 0.9855, almost 1, which means an almost perfect relationship.
Okay, so finally, for the results of discussion, we find that we have some sources of error where we have the factors of the angle of measurement when we were using the vernier caliper. Also, we have the table movement because we were rotating the person when we were making the measurements. Also, the accidental spring compression measuring because it was in the vertical y-axis, so it was a little compression. Finally, when we were comparing the values, we know that the theoretical spring was beyond our reach, so we couldn't compare the experimental result with another spring constant. But we have that our experimental results were 82.80 plus minus 0.14 newtons per meter. And also the suggestion for improvement, we have that we want to limit the person who were measuring in the experiment. Also minimize every other movement that were happening during the time. And finally, making sure that the person who were measured had this knowledge of how to move the vernier caliper. And finally, as a conclusion, we confirmed with our experiment that the Hooke's law was proved. Because we were knowing that the force annulation, as we saw in the equation, was proportional to the distance that the spring were stretched or compressed. Yeah, that's it.
Okay. Now you need to choose one of those and answer in less than a minute.
Okay, one per team or one per team?
No, one.
Okay.
Okay.
Who should start?
Where do you want?
Sí, que vamos.
Okay, dale.
My question is, what is the importance of organic measurements in the
Which number is?
10.
Okay.
Can I begin? Okay, well, there's many importance. First would be to reduce parallax error and the experiments observation error. You could also argue that it's a better way to measure each, let's say, each length or each elevation, since you're able to get a mean, which would be a better representation instead of each small measurement. From that, we're also able to get a standard deviation, which would be also the of each mean. Therefore, you're able to get more precise answers. And for me, it's like, why is it historical?
Number?
26. When analyzing the experiment necessary data, sometimes like if we want like a final result like to be accuracy, we have to like measure so many times. But it's also it's very hard to see and obvious like how exactly each part is. So we use the histogram to dividing the data, so we can see the frequencies like clearly, and we can just like get the result like easily.
My question is number one, what is slow and how does it relate to the spring constant? Well, slow is an equation that relates force and with the spring displacement. This is related to the spring constant, which represents how much force you need per meter to the spring.
In a modernist consent, how did you use recollect data to determine the value of the cake? Well, first of all, we need to find all our values to have the means of each of them. And then we use that mean to find the standard deviation, but it was also related to the question where we have this slope. And this slope were taking about the standard deviation, we will have the known value because we have how much the force needed to compress the spring and it's related to the distance that is stretch the
Okay. That's it. Okay. Don't your questions here at the back.
Picture and the email is already in the calendar, so I can literally send to you with the picture. Right?
Yeah. Great.
But that's for.
That's for today. See you on Thursday. If you want to pick up your other